Let us see how to integrate 1 upon 2 plus cos x. If you're thinking about multiplying and dividing by 2 minus cos x in the numerator and denominator, let me correct you right there. You're thinking about it the wrong way. If instead of this 2, it was 1 plus cos x, it would have made sense for me to multiply and divide by 1 minus cos x because it would have turned into an identity and an easy integral thereafter. But here it doesn't make sense to multiply and divide by 2 minus cos x. So then how do we integrate this? In order to integrate this, we do something called as Weierstrass substitution. Now, Weierstrass substitution can be done when your integral is of the type 1 upon a plus b sine x plus c cos x, where a, b, and c are going to be constant values. Weierstrass substitution says that you put tan of whatever angle you see here, take half of that is equal to t. So tan of x by 2 in this case is equal to t. Now, what is the advantage of doing tan x by 2 is equal to t? We try to convert this entire thing in the t world, but you will question that the derivative of tan is not present over here. So what do we do? Whenever the derivative is not present and you are doing method of substitution, you find the inverse of the function. So instead of directly differentiating, what you do, you just, instead of having t is equal to x by 2, just find the value of x from here. Okay, so what do I mean by this? So I can say that from here x by 2 is equal to tan inverse of t. Therefore, just multiply by 2, so you get x is equal to 2 tan inverse of t. Okay, why do I do this? Because the derivative of tan x by 2 that I'm putting as t is not present over here. Remember, in integration, whenever the derivative is not present, you first take the inverse of the function. So instead of having tan x by 2 is equal to t, just convert it in the form of x is equal to in terms of t. After taking inverse of the function, you can directly differentiate this. So in order to differentiate this, you can differentiate it with respect to t. So I have dx by dt is equal to 2 upon 1 plus t square. Remember, the derivative of tan inverse of t is 1 upon 1 plus t square, and 2 is constant, so it will remain the way it is. Okay, so from here, I can just get dx is equal to, just multiply that dt over here. So you get 2 dt divided by 1 plus t square. So you converted dx in the t world now at this point. How do we convert sin x and cos x in the t world? In order to convert sin x and cos x in the t world, we have to think of sin x and cos x in terms of tan x by 2. We know that for sine 2 theta, there is a formula, there is a half angle formula in terms of tan, which is 2 tan theta upon 1 plus tan square theta. And for cos 2 theta, the half angle formula that we have is 1 minus tan square theta in terms of tan, okay? 1 minus tan square theta upon 1 plus tan square theta. Notice that in these formulas, the angle becomes half. Whatever is on the left hand side, on the right hand side, it becomes half of whatever is on the left hand side. So we can actually apply the same formulas for sin x and cos x to convert it into tan x by 2, okay? And the way we are going to be doing it is just applying those half angle formulas. So let's see how. So that sin x can be written using this formula right here as 2 tan x by 2 divided by 1 plus tan square x by 2. Okay, remember, whatever angle is on the left hand side, it is half on the right hand side. And we know that tan x by 2 is equal to t. So we can just put it as 2t upon 1 plus t square. And for cos x, we can write it as 1 minus tan square x by 2 divided by 1 plus tan square x by 2. And this would just become 1 minus t square over 1 plus t square. Now, once you substitute those values in the integral, that will get converted into the t world. Let's move back to our original integral. We know that in order to integrate this, we can make a substitution, which is tan of x by 2 is equal to t. Notice that the angle that you choose here is always the half of the original angle present in the integral. Okay. Now, since the derivative of this tan x by 2, which is sec square x by 2, is not directly present, you have to take inverse of the function because before taking the derivative. So therefore, in order to take the inverse of the function, shift that tan on the other side, you get x by 2 is equal to tan inverse of t. Therefore, you can just multiply by 2 and say x is equal to 2 tan inverse of t. Now at this point, you can take the derivative because we have converted it to inverse form. So we can differentiate this with respect to t, and you will get dx by dt is equal to 2 is a constant, will remain the way it is. Differentiation of tan inverse of t is 1 over 1 plus t square. Okay. Therefore, in order to find the value of dx over here, we can just multiply by dt on the other side. So we get dx is equal to 2 times dt over 1 plus t square. So we were able to convert that dx in the t world. Now, how do we convert that cos x in the t world? We already know that cos x by half angle formula can be written as 1 minus tan square x by 2 divided by 1 plus tan square x by 2. Whatever the angle is on the left hand side, it becomes half because it is the half angle formula of cos. So this will become 1 minus t square over 1 plus t square. That is our cos x. So I am able to now convert cos x in the t world as well. So in other words, we can now convert this entire integral in the t world. So this is going to become 1 upon integral of 1 upon 2 plus cos x, which is 1 minus t square upon 1 plus t square. And instead of the dx here, I will write 2 dt upon 1 plus t square. Okay, I hope that makes sense so far. Now there is a bracket over here, okay? And here is also a bracket. So I can multiply this 1 plus t square inside of this bracket. So this will become integral of 1 upon, if you multiply 1 plus t square over here with 2, so you'll get 2 plus 2t square plus, and that 1 plus t square, as you multiply it with this term, this 1 plus t square and 1 plus t square is going to get cancelled. So you will be left with just 1 minus t square. I hope that makes sense because that 1 plus t square and 1 plus t square is going to get cancelled. And outside you have 2 dt. Such a beautiful integral and so easy to integrate now. Now you can just write this as integral of 1 upon this 2 plus 1 is going to become 3 plus 2t square minus 1t square is going to just become 1t square. Okay, and this 2 dt. Now this 2 is a constant value, can be taken out of the integral. So that integral is essentially going to be becoming 1 upon 3 plus t square dt. I hope that makes sense so far. Now I know the formula of integral, which is 1 over, we know the integral of 1 over x square plus a square. Do we know the integral of x square plus a square? Yes, we do. The integral of x square, 1 upon x square plus a square, the formula is 1 upon a tan inverse of x upon a. Okay, remember that formula for integral 1 upon x square plus a square. The formula is 1 upon a tan inverse of x upon a. So in order to now integrate this, we need to write this as something square. So can we write that 3 as root 3 square? Okay, we can write that 3 as root 3 square. So that will become x square plus a square. Okay, so we can directly apply the formula. So that will become this 2, I will write the way it is. Okay, the formula is 1 upon a. So this is x square and this is a square. So a is root 3 in this case. So that will become 1 upon root 3 tan inverse of x upon, or sorry, t upon root 3. T upon root 3. Okay, plus let's add the constant of integration c. I just apply this formula 1 upon a is root 3 over here, and instead of x we have t over here. Okay, I hope that makes sense. So now we can resubstitute the value of t and convert it to the x world again. So that will become 2 divided by root 3 tan inverse of, we know t is tan x by 2, so we can write tan x by 2 divide by root 3 plus the constant of integration c, and that is your final result. I don't think this was very hard integral. It was just a methodology that you have to follow.